There it is. All right, we're going to try this with the new gadget we got. Let's go over the calendar. Yesterday, you had a virtual day, which was a review quiz, had 10, 15 questions on it. Today we're doing test review, and we cut the 4B into 2 sections, so it has 2 parts. You're going to take part 1 tomorrow. It's like 45 questions. We will do the same thing we're doing today on Thursday, and we will take the second half on Friday. Next week, we will have final exam review for 3 days. After we finish with that, if you are a 1, 3, or a 5, which you guys are a 2, your second hour, on Thursday you will have study hall unless you start your final on Thursday, and some of you will because you got other stuff you need to do, and it may take you 2 days to get this, and that's okay. We will take your final in here on Friday, and when you are not taking your exam, you have study hall. So that's for the next 2 weeks. The next 2 weeks is going to be a lot of lecture, a lot of talk, a lot of practice, and exams. And that's just the way it is. This has been a really strange semester, and we need to do this to finish up. Now, that being said, before we left for Christmas break, we had about 45 students that were failing. I was very concerned, because last year we had 2 students the whole semester that failed. After we came back, we looked at them yesterday, and you guys have been doing your work, because there's only 12 on that list now. And the 12 that are on that list, let's get you guys off there, okay? And you can do it. But for the next 2 weeks, you're going to have to put your head down and work. We can't be dinging. So please put your phones up. Don't work on your phones today. Please work with me. We need to work on physical science. First order of business. Hi, kid. Grab a periodic table and a calculator if you need it, and away we go. The first thing we talk about is the pH scale. The pH scale runs from 0 to 14. In the dead middle of this scale is 7. 7 is neutral. Any substance that has a pH below 7 is called acidic, or an acid. What an acid is a substance that has these hydrogens that are available to bond with other substances in the form of hydronium. Water is H2O. That's what this symbol is. We're aware of that. But what happens is an extra hydrogen will come over here, and it will bond to a water molecule. The bonds that hold a water molecule together, the oxygen and the hydrogen, those are covalent bonds. Covalent means equal sharing. They share. A hydrogen bond is a very weak bond. It's right here, and that hydrogen will come in there, and it will just hold right there against that hydrogen, or the water molecule, and then when another substance is present, it will jump over and bond to it. That's why sometimes it burns. When you put your hand, or you have something that's really acidic or sour in your mouth, it'll kind of burn and it's sour. That's those hydrogens that are mixing with the spit in your mouth, and they're forming a new substance. Okay? So just remember, acidic is below neutral on this scale. Now, this is what is called a logarithmic scale, meaning every time you move a number, when you go from 7 to 6 to 5, a pH of 6 is 10 times stronger than a 7, not 1, but 10. A pH of 5 is 10 times stronger than a 6. Does that make sense? Okay. Now let's go to the other side of this scale. On the other side of this scale, you have what are called bases. Bases have this OH in there, and when we were studying polyatomic ions, OH is called hydroxide. These things are found in base solutions. They're just an ion that floats around in there, and it's made up of an oxygen and one hydrogen. It has a negative charge on it. The hydrogen, the free hydrogen, happens to have a positive charge, and we'll talk about that in a minute on the periodic table. Okay, the more of these OHs that are available in that solution, the stronger the base. And the base goes in the exact opposite direction from acids. So you have 7 and 8 is 10 times more. There's 10 times more of these available than in a neutral solution. In a neutral solution, there are not hydrogen available to bond, and there are not hydroxides available to bond. That's why it's called neutral. Pure water is neutral. Okay? Why do I harp on this? pH is extremely important in your body. You have HCl in your body. Do you know what that stands for? We've worked with it some. That's hydrochloric acid. Anytime you see an H in a chemical formula, it is most likely an acid. If you have an OH, this is sodium hydroxide, and we used this last week, or when we were here last, when we were doing our labs. When you see OH in the formula, it is normally a base. Here's what's happening. If you have an acid and you add a base to it, the acid has these hydrogens. You add the OHs to them. What happens when you put H and OH together? What does it form? An H and an OH. Yeah, it forms water, right? H plus OH is H2O. That's water. The other stuff that is involved in this equation, when you have HCl and this is sodium hydroxide, it is going to produce, where's it at? Yeah, it's right here. HCl and sodium hydroxide gives you water and NaCl. Do you know what NaCl is? You remember salt? The salt that's on your table? That's what that is. When you combine these two substances, this is what is produced. This is called a neutralization reaction. What that means is you take a base and a base on this side and an acid. When you put them together, they pull the pH of that solution closer to neutral because they're neutralizing. They are making water and salts. That's what's produced in a neutralization reaction. So if I ask you tomorrow what happens in what is produced in a neutralization reaction, what are you looking for in the answers? I can wait.
Sorry.
Okay, listen to the question. In a neutralization reaction, what two things are always produced? H2O, which is water, and what's the other? And a salt. Yeah, and a salt can be NaCl, like table salt. Calcium chloride is a form of salt. We'll call it a salt too. So that's the two things that are formed. Okay? When you eat and you swallow, where does that food go? Goes to your stomach, right? What happens to food when it's in your stomach?
Breaking down the stomach acid.
It what?
Broken down the stomach acid.
Okay. It'll break down a little bit, but what's the primary job of that hydrochloric acid? And it's very strong. The hydrochloric acid in your stomach is a 2. It's about a 2 to a 3. If it gets on, have any of you ever heard of indigestion? When you get the acid that comes up into your esophagus, right? It hurts, doesn't it? Do you know why?
It burns.
Yeah, it burns because it's acid. It's a 2 to a 3. Why doesn't it burn in your stomach?
Because of the outer wall.
What's on that out? What? It's on actually the inner wall of your stomach. My stomach's a little bigger than yours.
Is it the base?
There is a mucus lining in your stomach, okay? Mucus is snot, that's what it is. But that protects the lining of your stomach from this acid. Why would your body produce something so strong that if that mucus wasn't in there, it would eat a hole in your stomach? Why would it do that? Okay, when you eat something, does it have bacteria on it? Yes, it does, doesn't it? It has a lot of it. If it's not cooked properly, it has so much that the acid in your stomach can't get rid of it and you get food poisoning. That's why you have to cook your meat, especially chicken. You've got to cook that until all that bacteria is killed. So you have to raise the temp on it, right? So that acid, that's what's used to help kill the bacteria that enter your body when you eat, okay? Now, what happens to all that food when a pH of about 2 is mixed, and let's just say that the pH of the food that you eat is somewhere around 7. Lemons will be down around 4. That's why if you eat a whole lot of lemons, you get a sour stomach. You're putting so much acid in there that your stomach's kind of going, that's too much. But if you eat normal food, it's around 7, 6 most of the time. So what's going to be the pH of that food when it leaves your stomach? What is the pH of the food that leaves your stomach roughly?
4 to 5.
Yeah, how did you get your answer? Okay, she took the pH of your stomach acid is about a 2, and then the food is about a 6, so the midpoint of that is going to be somewhere between 3 or 4. That's exactly right. Is that going to be hard on your bloodstream? The answer is yes. Do you know what the pH of your blood is? And it's extremely important because if it changes more than like a half point, your body doesn't work anymore. Your muscles won't work and your body starts shutting down. Your blood has a pH of 7.2. It's almost completely neutral. So when that food comes out, where does it go after it goes into, when it goes from your stomach, where does it go in your body? Do you know? Not yet. Not yet. That's in the bloodstream. It's oxygenated in the bloodstream, you're correct, but not in the digestive tract. If it was oxygenated there, you would have gas. And we all know about that. Okay, so let me ask the question again. And man, you guys need to know this from biology. Where does food go after it leaves the stomach, after it's mixed with this acid and it's kind of sterilized or sanitized? Where does it go? It goes into the small intestine. The small intestine has 3 parts, and the first is the duodenum. When it reaches there, there is an organ that produces a couple of hormones and substances that is called your pancreas. You ever heard of your pancreas? You can't live without your pancreas. It's a finger-like organ, sits right above your liver, or right behind it actually, and it stretches all the way across your body. There are 2 types of cancer that it will get you in a hurry. If you're diagnosed with either one of them, the average lifespan is about 6 months, is about the outer limit. But if you get a brain cancer, it gets you very quickly, and the other is pancreatic cancer. Pancreatic cancer is terminal in a hurry. You know who Patrick Swayze is? Patrick Swayze was the guy in Dirty Dancing. He was the dude, a great dancer, and he was an actor. But anyway, he got that in it wasn't 6 months, he was gone, and he became a skeleton. I think that's what Steve Jobs had. I think. And when you see his last days, Steve Jobs was a skeleton. You know who Steve Jobs was? You guys owe him a great deal because all of these phones, the iPhone, he invented it. So he changed the game. But anyway, back to this. The pancreas will raise the pH of the food that you ingest in the small intestine back to around 7, so it's safe for your bloodstream to use. Okay? So that's why pH is important. It's very important. In the neutralization process, what are the two things that are produced? It's right in front of you. Water and salt, very good. What is this right here? When this extra hydrogen attaches to a water, what is that called? It is with a hydrogen bond, that's exactly right, which is easy to break. Do you know what that molecule is called?
Which one?
This one.
Hydrogen?
Hydronium. Hydronium is H3O. Now, when water breaks down, it will form this hydronium and then this hydroxide. So that's how acids and bases are formed. When there are more hydroxides being formed, you have a base. When there are more free hydrogens with hydronium over here, you have an acid. Okay? The bonds that hold a water molecule together are covalent bonds. They are stronger than hydrogen bonds. The hydrogen bonds are what hold that extra hydrogen on there, and they're broken very easily. And that kind of makes sense. Okay, let's see. So what number is neutral on the pH scale? 7, that's right. Which of the following would be an acid? Which of these following substances? One that has a pH of 12, 10, 8, 7, or 4? 4, because it's on the acidic side. Okay? Which one would be neutral? 7, because it's in the middle, and anything above is a base. The farther away from 7 you get, the stronger the base or acid. When you mix an acid and a base together, what happens? What happens to the substances? That's right, they are neutralized. Okay? Very good. Now, if a substance loses hydrogen, the hydrogen gets bonded together. It's not free anymore. What happens to the pH of the substance? Does it go up, down, or remain the same? I'll ask it again. You guys, if you'll read the questions, you can think through these. I have free hydrogen available in a substance. As less hydrogen is available, it bonds up with hydroxides to form water. Will the pH of that substance go up, down, or remain the same? Okay, let's think about it. The more hydrogen that's available, is the acid stronger or weaker as you get more hydrogen available? It gets stronger, so the pH goes down, right? As these bond up and there are fewer available, what happens to the pH? It goes up. It neutralizes towards the base end. Okay? I can ask you another kind of question. If I have more hydroxides available, as the hydroxides available increase, what happens to the pH? Does it increase, decrease, or remain the same?
Does it increase?
It will increase, that's right. As more of these are available, it increases. Do you remember way back from correlation? As one thing increases, the other one increases. That is a positive or a direct relationship. That's what we have here. When one thing increases and the other one does, that is a positive or a direct relationship. The graph will ascend or go up. If one thing goes down and the other one goes up, Then you have an inverse or a negative relationship. So remember those. There's a couple questions about that on there. Okay? Very good. Let's see what else we got here. Which of the following pH readings would be a base? 10, 7, 5, or 100?
10.
10. How come?
Because 100 doesn't exist and 10 is.
Yeah, you can throw 100 out, right? Because the scale only goes to 14. And a base is above 7. So any number that's above 7 is a base. If it's below it, it's an acid. All right. How much stronger would a pH of 4 be than a pH of 5? Listen to the question. How much stronger is a pH of 4 than 5? 10 times. Each time you move, it's a 10 times. Okay? All right. What type of bond is found between oxygen and hydrogen in a water molecule? What type of bond holds the oxygen and hydrogen together? Covalent. That's right. Covalent. Okay. Now, water is what's called a polar molecule. That means it has a positive side and a negative side. The oxygen side up here, this is the negative side, the hydrogen is the positive side. Okay? So that's about enough for the pH scale. We will put it up here. And we've talked about this one, so we can put this one back. What type of reactions are these? Neutralization. These are neutralization reactions. Okay. All right, let's pull this down. Mole theory. We need to talk about moles for a little bit. Now, when we are talking about mole theory, the reason it was invented is atoms are extremely small, and I mean extremely small. There are 6.02 times 10 to the 23rd particles in a mole. When we are talking about moles, you can talk about atoms, you can talk about molecules. What are the difference in atoms and molecules? I can wait. Atoms are smaller. What are molecules composed of? Atoms that are what?
Bonded together.
That are bonded together. For instance, oxygen is an element. Okay? It normally bonds to another oxygen. That's why when you go to the hospital and on the wall, if they're giving you oxygen, it says O2, because the stuff that's going into you is two oxygens put together. It doesn't tend to stay in just by itself. Anyway, you have molecules. H2O, what molecule is that? Oh, wait. It's water. 2 hydrogens and 1 oxygen. Now, a mole of hydrogen has 6.02 times 10 to the 23rd particles in it. How many particles are in a mole of water? 6.02 times 10 to the 23rd. This is called Avogadro's number. Have you ever heard that before? Yeah. Avogadro was a famous chemist, and they came up with mole and particle theory after he died, but they named it in his honor. Okay? What that means is you have 6.02, it is 6, and then behind that decimal there are 23 zeros Hexillion. That's how many zeros are back there. To put that in perspective, let's think of it this way. How many donuts are in a dozen donuts? 12, right? 12 is a dozen. How many donuts would be in a mole of donuts? 6.02 times 10 to the 23rd. It's a pretty big number, right? If you had that many donuts, would they fill up a grocery bag? Yep. Would they fill up a dump truck?
No.
Would they fill up the Grand Canyon?
No.
What would they fill up? Would they fill up the earth? Be kind of close. If you took donuts and you stacked them up and there were a mole of them, they would reach from the earth to the sun 200 million times. That's how big that number is. And what that tells you is that's how small an atom is. Now, how big is a mole of water? A mole of water molecules. We use it every day. If you take your hands just like this and you fill it about halfway up, that's about 3.5 teaspoons. That's a mole of water. But a mole of donuts, which donuts are about this big around, they will go from here to the sun. If you had a mole of basketballs are about this big, you could completely fill the earth with basketballs, with a mole of basketballs. Okay? So, that tells you two things. One is, a mole is a very, very large number. And atoms are extremely small, and that's what you have to use to talk about particles and atoms. All right? So let's see where we go from here. We talked about all that. Yeah. Which is going to have more particles? Which one has more particles? A mole of hydrogen, and if you look on your periodic tables, a mole of hydrogen is number 1, it's in the upper left-hand corner. A mole of hydrogen or a mole of fluorine, which one has more particles in it? It would be the same. That's right. And that's what we're trying to teach you. Now, here's the other question. Which one has more mass? Which one has more molar mass? Hydrogen or fluorine? Fluorine. How many times heavier is fluorine than hydrogen? Look at the numbers in the boxes. Fluorine is 18.998, which is 19. Let's just say 19. What is hydrogen? Yeah, so if we look at it kind of generally, it would be 1. How many hydrogens would you have to equal the mass of fluorine? 19. So if you had 1 ounce of fluorine, how much hydrogen would you have to add to it to equal it? 19 ounces of hydrogen. Does that make sense? This is all based on mole theory. Okay? Pretty good, crew. Now, isotopes. Hydrogen, and the reason we have all these decimals is that is an average. Not all hydrogen atoms weigh exactly the same. Some of these hydrogen atoms have an extra neutron in them, and that makes them a little bit heavier. So that's why we have this decimal. There aren't a lot of them, but they are there. Have you guys ever heard of carbon-14? Did they talk about that in biology with you? Carbon-14 is used to date things, like if they find a fossil or a dinosaur and they're trying to find out how old it is, they use carbon-14 dating. What that means is they can predict, or they know how much carbon-14 is supposed to be in a substance when it was born or when it was created. It will start losing that over time. And they can measure how much carbon-14 is left, which is an isotope of carbon. It has two additional, carbon normally weighs 12 when it has 6 neutrons, but if it has 2 additional neutrons, it goes to carbon-14, and they use that to date things. That is an isotope. An isotope has additional neutrons. It will weigh more. Okay? Now, can an element have additional protons and still, can hydrogen have more than one proton? No, it cannot, because when you add a proton to hydrogen, it becomes helium. That is what makes the element identify itself. Okay? The only thing that can change are neutrons, and then the electrons can be shared. That's how energy is stored and released. Okay? And we'll get into that in the test too. We making sense? You guys okay? All right. Is a mole equal to Avogadro's number?
Yeah.
Yes, it is. That's what it is. Now, in a chemical equation, let's go back over, where's it at? Here we go. This is a chemical equation. What's being formed here? Stay with me, come on. Water. You're combining hydrogen and oxygen, and you combine them, takes a little bit of energy, and you get water, H2O. In front of hydrogen, you have a 2. That's called a coefficient. A number that's in front of them is a coefficient. A number that is written below and behind that element symbol is called a subscript. The coefficient tells you how many moles are being used in that equation. In this reaction, it takes 2 moles of hydrogen, 1 mole of oxygen to produce 1 mole of water. Okay? I'll say that again. It takes 2 moles of hydrogen, that's why the 2 is here. If there's nothing in front, it's an assumed 1. 1 mole of oxygen will produce 1 mole of water, H2O. When you are balancing equations, that's why you cannot change the subscript, because it changes the molecule. But you can change how many of the particles are being used in the equation. Okay? All right. See what else we got here. How big would a container be that held a mole of carbon? We actually had a lab on that. Yeah, it's about that size, isn't it? Those little flasks has about that much carbon in there. That's a mole of carbon. So atoms are small. Are atoms and molecules both considered particles in chemistry? Yes, they are. Atoms and molecules are both considered particles in chemistry. This is a mole, right? 6.02 times 10 to the 23rd. How many particles would be in half a mole? 0.5 moles. How can you cut this number in half? Okay, here's the way you do that. Leave the 10 alone, 10 to the 23rd, leave it be. But you can cut this number in half, and that would be half the particles. So how many particles are in half a mole of water? 3.01 times 10 to the 23rd. And on your test, when it's written like this, 6.02 times 10, and then it has this to the 23rd, that's what that means. This means it is an exponent or a superscript, okay? Because I can't get the thing to put it up there. It just takes too long. So I did that like that for you, okay? Let's see what else we got here. Then we talk about molar mass. The molar mass of salt. Do you remember the chemical equation for salt? NaCl. So if I want to know the molar mass of a salt molecule, I have to go to the periodic table. I find 22,989. Write it right here. And then I add chlorine. Chlorine's right here, 35.453. I get that number. That will be the molar mass of salt. And I'll ask you the molar mass of some things. I'll ask you how much 1.5 moles of carbon dioxide weighs. How would you find that answer? If I wanted 1.5 moles of carbon dioxide, how much does it weigh? How would you find that answer?
Find the molar mass and just divide it by 2.
Would you divide it by 2? Okay. Let's put this up here. 1.5 moles of CO2 equals blank grams per mole. Okay? If I have 1.5, I need to know how much a mole weighs, right?
Mole is divided by 2.
And then what would I do? If I divide the mole by 2, I would have 0.5 moles, how much a 0.5 weighs. But the question wants 1.5, right?
Oh.
So I have to take the molar mass, which is CO2, and this is 16 and 12. It's about, what, 28? Let's just say 28. So one of them would be 28. What would I have to do to get 1.5? Add 28 and 14, and that would give me the grams per mole of 1.5.
Where did you get 14?
Where did I get 14?
Yeah.
Okay. Carbon weighs about 12, right? 12.01. Oxygen weighs 15.999. Is that right? When I add those together, I am going to get 27.999. That's how much 1 mole weighs. Now I can do this a couple ways. One is I can take this number and multiply it by 1.5. The other way to do it is go, all right, I got 27.999. That's how much 1 mole weighs. I need another half, so I cut this number in half, which is about 14. That's where that 14 came from. It's about half that number. Okay? And that'll give it to you. You guys got it? If you will think, if you will just think a little bit, you guys will be just fine. Okay? Now, any of your assignments that you don't have, get those in by next Thursday, and let's get you guys to pass. We don't need to take night school or credit recovery or all that stuff. Just suck it up for the next couple of weeks and get it done. Get it done what you need to do to pass. Okay? Because we don't want bad stuff to happen to you. All right, that is it. Let's turn this thing off.